Hi guys, let's move on and talk on logarithm. So logarithm can be established from indices. So if we have x raised to power m, like we usually do, and then let's say it is y is equal to x raised to power m. Let's make that more clearer. Y is equal to x raised to power m. So with that, we can see that we want to introduce logarithm. The rule is very simple. Okay, so we would say that m, this y we push x forward, m comes to the other side. So if we introduce logarithm, we're saying that m is equals to log x, log y of base x. So that means my x becomes the base, okay, and my y becomes what? The number. So definitely if I have 25 is equals to 5 squared, so I'm saying that 2 is equal to log 25 to base 5. Also, if I have 9 to be 3 squared, I'm also saying that 2 is equals to log 9 to base 3. And if I have 81 is equals to 3 raised to power 4, I'm saying that 4 is equals to log 81 to base 3. Now, questions can come in handy, so we can have a summary of this. Let's have it in red. That if a is equals to b raised to power c, then c is equals to log a to base b. Log a to base c. So question can come in handy and say that what is x if x is equals to log 2 base 16? Now, definitely we've seen this before. So that means we're saying in this case that our x is c, and our 2 is b, and our 16 is a. So we are saying that 16 is equals to 2 raised to power c, 2 raised to power x, right? So 16 is 2 raised to power x. So in that case, what will I multiply? How many times will I multiply 2 to get 16? So we know that 16 is equals to 2 raised to power 4. So definitely my x is equals to 4. Now we can also have given 4 is equals to log x, it's 1. So definitely what I'm saying is 4 raised to power x, no, that means I'm saying that 81, that means we are saying 81 is equals to x raised to power 4, because according to this law here, if a is equals to b raised to power c, and then definitely c will be equals to log a to base b. Okay, so this is our c here, this is our a, and this is our b. So definitely 81 is equals to 3 raised to power 4. So my x is equals to 3. Okay, and questions can come on like that, and you just have to be very sensitive enough to remember this law. So we want to really talk about the rules of logarithm, but before we talk about the rules of logarithm, we want to talk about the basic two different bases, the two main bases. So we have log to base 10, and we also have log to base e. Okay, this is what they call exponential logarithm or natural logarithm. Okay, natural logarithm, and the exponential number is given as 2.71828, and it goes on to infinity. So instead of writing, we can write let's say we can write log 10. Log 10 is very common. Okay, so if this is called natural logarithm, we can call this common logarithm. Natural logarithm. Okay, so if we have log 10, so base 10 base 10. Okay, so definitely here, if you have write this as log 10 to base e rather, so this can be written as log 10, because most of the times if the base is 10, you just write it simply as 10, and if the base is e, we change it to ln ln, or people call ln e, so ln 10. Okay, so it can be written as ln 10. So I'm saying that log to base e of 20 is equivalent to ln 20, and log to base e of say minus 1 is equivalent to ln minus 1. So this is an alternative form for log to base e. Now, before we go further, let's talk on the rules of logarithm. The rules of logarithm is quite similar to that of indices. So we can establish that now. So number one, it says that log x multiplied by y, everything to base a, so a common base, okay, is going to be equals to log x base a plus log y base a, provided they have a common base. Okay, now number two, we have that log x divided by y to base a. In indices, when it was multiplying, we added, and subsequently it happens also in logarithm. When we have a multiplication, we added, and now when we have a division, we will subtract. So it will give us log a, log x base a minus log y base a. Now remember in indices that we had x raised to power n raised to power n is equals to x raised to power m. Now in the case of logarithm, where we have log x raised to power n to base a, now the n here becomes a coefficient. Okay, it comes to the back to become a coefficient. So we have it to be n log a log x to base a. And number 4, if we have log a log 1, and this is one of the laws of logarithm. Okay, um log of 1 is equal to 0 irrespective of the base. Okay, irrespective of the base, because from the laws of power, that anything raised to power 0 is 1. Therefore, the definition of log 1 of base a will be equals to 0. Okay, so and we can prove that after we understand the next one. So let's say 5 log a, if we have same base same power. Okay, same base same power, so we have it to be 1. So now if we go back to log a raised to power 1, and we can say that if take 1, anything raised to power 0 is 1, so we can say that a1 is equals to a raised to power 0. So if I substitute 1 to be a raised to power 0 in this, so I have log a raised to power 0. Now if I apply the rule, if I apply log, if I apply this rule, I mean log a, sorry, log x raised to power n to base a will be equals to n log x to base a. So that means my 0 becomes a coefficient. 0 log a, right? So obviously anything multiplied by 0 will give me 0. And since these two have the same base and same power, so I can say it's 0 multiplied by 1, which will give me 0. So definitely we have our loop being expanded here. That's a logarithm of 1 irrespective of the base is 0. So number 6 now. Number 6, we say is log a to base a all raised to power x. Okay, raised to power x. Now if you apply this law, if you apply the same law here, so we are saying that x to give me log a to base a. Now in this case, you know our log a base a is equals to 1, so this will give me x. So I'm saying that log a raised to power x to base a is equal to x. Okay, and we also have another rule that says that a raised to power log a x is equals to x, because just as log a base a is equals to 1, so is a raised to power log a. If you have something like this, it's also equals to 1, so we can keep that in mind. So here the same way we had inverse law on logarithm that says x raised to power minus m is equals to 1 over x raised to power m. Also have that kind of inverse law in logarithm, such that we can say log a log b to base a, right, will be equals to 1 over log b log a to base b. Okay, so that means at first the base was at was a, then next one the base becomes b, and this becomes at the denominator. So these laws, okay, so we have 8 rules here. 8 rules: 1, 2, 3, 4, 5. We have 6, okay, 7, and finally 8. So well, with these we can attempt quite some questions. So we proceed. So let's try to have 8 questions on each. So that means 1 question on each law. So let's say we have log a, log to base a of 6.788 multiplied by 1.43. So definitely we apply the law of logarithm here. We are splitting both ends so that each will have their individual log. So this will give me log a log 6.788 base a, and since this is multiplication, it will be addition to log 1.043 to base a. Okay, and let's have number 2. Let's have log a into 3 divided by 4. So this will give me log to base a of 3 minus log to base a of 4. Okay, now moving on, let's assume we have logarithm of 8 to 1. Remember that anything log 1 irrespective of the base is 0, so our answer here is 0. And also we have log to base a of 3 raised to power 4. So this 4 goes back to become a coefficient as we've learned. So this will give me 4 log base a of 3. Number 5, if we have log 10 to base 10, remember it's the same base and power, so in that case it will be equals to 1. And let's take another one that has log 3 of 27. Log base 3 of 27. Now remember that 27 is 3 raised to power 3. Okay, so in that case, if we substitute that back, so we have it to be log base 3 of 3 raised to power 3. Now this 3 goes back and become a coefficient according to this law what we applied here. Okay, it's also applicable here. So that means we are saying that log a of x raised to power y is equal to y log a of x of base a to x. So this makes this have 3 log 3 to base 3. Now log 3 to base 3 is 1 because they have same power. So this will give me 3 by 1 and the answer will be 3. Okay, so let's have another question that says given we have 3 raised to power log 3 log to base 3 of 4. Now we know that everything in this circle, yeah, is equals to 1. Okay, so our answer will be 1 by 4, and that'll give me 4. And number 8, if we have 1 over log 3 base log 4 base 3, I want to invert it so that our base will change and our our power also will change. So we have log of 4. The 4 becomes the base and the 3 becomes the power number. So irrespective to this last thing, we want to talk more further on change of base before we wrap up this video. Change of base. Okay, now what does it mean to change base? We might like here we change from base 3, we change from base 3 to base 4. Now we can also move from a different entirely base, just like we've done so far, such that we have a formula. Let me just give you straight to the point. We have that log a to base x, okay, can be changed to log to base b. Okay, so we have it to be log b of x divided by log b of a. So we are introducing a new base entirely. So this is a change of base formula which relates the logarithm of a number relative to two different bases. Okay, relative to two different bases. So in that scenario, to change base we just have to apply this. So I might want to change given log 3 base 4, and the question says change with respect to base 10. So that means I'm saying that my log base 3 to 4 will be equals to log 10. Okay, I take my number first of 4 divided by log 10. Okay, I take the base as the denominator of log 3. So wherever they ask you to make subject of formula, it's very easy. So in the case of logarithm, which is on like indices, if they ask us log this, we can easily type in on a calculator to get our answer. Okay, so instead of going through the long process and everything, I'm going to type in your calculator and get your answer. So next one, we can also have equations that have logarithm embedded in it. So that will be called logarithmic equations. Okay, logarithm equation. So in that scenario, we would come back to that in the next video.